Assalamu alaikum, sir.
Yeah, Walaikum Salam, Halima. How are you?
Alhamdulillah, sir, I'm fine.
Okay. Why are you joining so late?
Sir, the meeting was incorrect, so that's why.
Oh, you got. Okay. So much
I
of time
wasn't
has been
able
wasted.
to join.
Okay. There's so many questions left, and we need to hurry up and we need to complete that. Okay.
Yes, sir.
Hmm. Your exam is on 9th of September, so we don't much have time. We don't have much time
October.
left. 9th of October, yeah. See, so question number 22 is given here, which says that Adia built a circuit in her school lab, which is given below. What type of connection is used between bulbs A, B, and D here? What type of
Uh,
connections have been used between them?
Sir, it's parallel.
Parallel connection is used now, obviously, because we know that appliances connect appliances, whether it be bulb or any other appliances, they can be connected in two different manners. One where basically the two terminals, like one where basically the two like terminals of the appliances are connected together here. Like for example,
Yeah.
the positive terminals of all the appliances are connected together with this wire, and the negative terminals of all the wires of the negative terminals of all the bulbs are connected together. So such a
Yeah.
connection where the like terminals of the appliances are connected together, so that becomes a parallel connection. That is called as a
Hmm.
parallel circuits connection. Okay, but in the series connection, basically one appliance is directly connected to another appliance here.
Yeah.
Getting it? Na? The end of one device is being connected to another device directly. Okay, now the
Hmm.
beginning of one device is being connected, like the ending of one device is being connected to the beginning of other device. So that is a
Yes.
series circuit connection. Okay. Question number B was also there. One second. That's question number 22. Mm, 22. Where's question number 23? Oh, hold on a second. Where did the question number 23 go? Hold on a second. I think I have no, missed some question here, Halima. Question number no, 23. Mm, oh, 4 5 questions are skipped here. Okay, I will take that later on. Okay, na? Halima, question number 23, 24, 25, 26, and 27. Okay, those 5 questions I cannot find it here. Give me a second. Just give me a second. Maybe I can find it over here.
Okay, sir.
Mm, no. There might be some error in this. Okay, anyways, let's continue with question number 28. Okay, na?
Sir, actually, there is a in the before questions. We have discussed a little bit in the class in
Mm-hmm.
my school. So not this one, the other one, like the MCQ type questions.
Yeah, tell me.
In this, yeah, no, the other one before.
Hmm.
So in this, my teacher told that which one is it? Yeah, sir. In the 10th question, it says it's divided equally among the branches, right? The answer.
See, the question here is that in a parallel circuit, what happens? In a parallel circuit, what happens to the voltage across different branch? Uh,
It
so what
divided
we
equally.
see, it's a parallel circuit. So the voltage across different branch, it will remain same actually. No, it is equal to the same as I told you. If you were to talk about it, the right answer is that it remains same. Voltage will remain same across each component. Like take a look at this circuit once again. See, in this parallel circuit connection, the voltage across every bulb will be same. Getting it now? Each branch is that is being direct, like all the branch will be directly connected to the power source now. Like there will be some power
Yeah.
source over here, a battery, or electricity directly coming from the uh, directly coming from the source station, from the power
Mm-hmm.
station, right? So every bulb will be getting the same amount of voltage here. Actually, it will remain same. I think your teacher is saying it incorrectly. Actually, getting it now. So voltage across.
Sir, what is the answer?
The answer will be that, as I said in the last class, it will be same as I have said in the last class, that it remains same. Getting it? It remains same as the supply voltage. The same as the supply voltage. Got it?
Sir, isn't it always different in each branch?
No, no, no. It is not going to be always different in each branch. Okay, no? Now, when we talk about the series circuit, so in series circuit, it happens different. In the series circuit, the voltage
Okay.
will be different. The voltage across each branch will not be constant. Getting it now? That's the thing. Like for
Okay.
example, let me give you an example. Sorry. Suppose that you are having a 9-volt battery over here,
Hmm.
right? Okay. And it has been connected to different appliances. Okay. Let me get to the diagram here. Suppose here in the series circuit, it has been connected to a 9-volt battery. All right. And all of these are connected in a series. Okay. So you will see that all of these bulbs will be glowing differently actually. Getting it? Voltage is being shared among all these bulbs, but it is not being shared equally right now.
Oh, okay.
So that is the thing here.
That
So
will be only for series. That way, it will be different in all the bulbs. But in
hmm,
parallel, it will
same,
same voltage
exactly. So in a
for
series,
all the
the
bulbs.
last bulb will be glowing dim.
Yeah.
Getting it? In the series
Okay.
circuit, all the bulbs connected in the circuits will on all the bulbs connected in the series will glow, but their brightness will diminish as more bulbs will be added here. Okay, na? So thereby they will become dim and dim, like that. Okay, na?
So
So
only the
that
first one will glow bright than the other.
the thing is that as you add on more bulbs here, so the brightness of all the bulbs will start to gradually decrease. Understanding
Okay.
it?
Yes, I
That
did.
that is the thing. So the voltage from the power source here is being shared among all the bulbs here, right? So each
Yeah.
bulb is now receiving less voltage. Understanding it? Like suppose if you had connected only one bulb in this, so it will be receiving all the voltage. But now when you have connected two bulbs, so thereby each of them will be receiving half of the voltage. Understanding it like that?
Yes,
But
sir, I did.
in the parallel connection, if you suppose having a 10-volt power source, so each of them will be receiving the same amount of voltage. Hope that is clear.
Yeah.
Okay. So moving to question number 28. See, we need to understand like how to balance the chemical equation. Okay. So to balance the chemical equation, first of all, you need to count the number of atoms of each element on both the sides of the unbalanced chemical equation. Okay, now like the first thing is that you have to count the number of atoms of the reactant and the product. On the left side of the arrow, that is reactant. On the right side of the arrow,
Okay.
that is called as product. You know
Hmm.
that? Okay. So first thing is that you count the number of atoms of each element. Okay. So for example, take a look at this. Take a look at a simple example. Okay, now before taking this one. Suppose, for example, here a compound is given like C3H8. That's a compound, and you are
Hmm.
reacting it with oxygen. Okay, and on the product side, you are getting
Okay.
water and you are getting carbon dioxide. All right, you are getting
Oh,
water and you are getting carbon dioxide. Suppose so, carbon, hydrogen, and oxygen. These are the three different elements here, right?
huh?
And here again, you are having carbon, hydrogen, and oxygen, right? Carbon,
Yeah.
hydrogen, and oxygen. Okay. If an element has been written like this, like for example, there's carbon written in this manner. So how many atoms are there? There are there's only one
Uh,
atom.
okay, yeah,
One atom.
one atom.
Suppose if it is written as C3, so how many atoms are there?
Three atom, three atom.
Three atoms. Okay. Now suppose if I were to make a change here, if I were to write it as 2C, so how many atoms are
Nine
now?
atom. 1.
Two atoms. I have written two here, no? See,
Oh, 2. Okay, okay, okay.
here two is called as the coefficient. Okay, and
Hmm.
that is called as coefficient. All right. Okay. So here I have written two, so the number of atoms will be two into one, that is two. Suppose if I have written two into C3, right? So how many carbon
Yeah.
atoms are there? This two will be multiplied with the prefix. Three here is the prefix,
6
right?
atoms.
Two here is the suffix coefficient, and that is the prefix here. So two into three, there are six atoms here. Understood it now?
Yes, sir.
Okay. Now answer the following thing. How many carbon atoms do you see here?
3,
Three. Hydrogen,
8,
oxygen,
and 2.
two. And here, how many carbon atoms are there? Only
2.
one. No, one, no. Only one here.
Oh, sorry, sorry, 1, 1, 1.
Okay. Hydrogen is how many? Two.
Hydrogen is 2.
Oxygen
And
is
oxygen is
three.
3.
Two oxygen atoms here. Look here. Two oxygen atoms
There
here
are
and
2 there and 1 there.
one over here. Okay. So first step is completed. First step is that you count the number of atoms of each element on both the sides. Okay.
Hmm.
Then next, what you are going to do is that, like, as we have made a list of
You're
the
supposed to
atoms on
add,
both the sides. Uh-huh.
yeah. You're supposed to add.
Hold on. So, what we are going to do here, like here we are having three carbon atoms, here we are having one. Okay.
Yeah.
If we were to make it three, what can we do? We can
In,
write three here. It will become three
what?
carbon atoms. We
Oh,
can do
yeah.
that. Okay. So first of all, we will start with the single elements here. Like we can start with the single elements here. Okay, now. So for example, what I can do here, if I were to multiply it with three here, so one will be cancelled. Like I can write three here. So now the
Huh.
number of carbon atom on both the side has been balanced. No? Three carbon atoms here, three carbon atoms here.
Sir, we can should we multiply it with 3 so that 3 ones
Huh,
are 3, 3 here.
exactly. We'll be basically multiplying it.
Or should we add?
No, 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 we will be multiplying it. One into three, that gives us three here. Getting it?
Okay.
Okay, so carbon atom has been balanced. Basically, we have put a coefficient here. Okay, now we have
Huh,
put a
yeah.
coefficient here, right? Okay, so the coefficient three in front of the carbon on the right side here is indicating that there are just three carbon atoms here. All right. Okay, just as this subscript, no, like this three here, that is subscript.
Subscript.
Okay, that is subscript. This three here is the coefficient.
So,
Okay, if the number is
there
written
is
in
one
front,
more.
that is, you repeat.
There is one more method which is crisscross method. We can do instead of that also, no? Instead of this.
Yeah, those methods are also there. We can follow that also. So carbon has been balanced. Okay,
Yeah.
three here, three here. Okay. Next, look at hydrogen. Okay. Here are eight
Into 4.
atoms, and here we can multiply it by four to get eight now. Okay.
Yeah.
So we are going to put four here.
Correct. 4 there.
Okay. Okay. So hydrogen also has been balanced now. Now you look at the new number of oxygen atoms on both the sides. Here there's only
Yeah.
two oxygen atoms, but now the number of oxygen atoms have increased here. You see?
You just you take out 1 from it, so it will be balanced.
No, no, look here, look here. Earlier there were three now, but we have added two coefficients now. Three is the first coefficient, four is the second coefficient which we have added here. Okay. So
Hmm.
3 into 2, 6, right? Coefficient will be multiplied with the subscript. 3 into 2, 6 oxygen plus 4. If nothing is here, so we have got 1. So 6 plus 4 into 1. 6 into 1 plus 4 into 1. So that is 6 plus 4. So now you're having 10 oxygen atoms here. Here you have 2. Here you're having 10. So how about we write 5 here? We multiply this by 5. Want it to become 10. So 10 oxygen atom on both the sides. Getting it, Halima, what I'm trying to say?
Sir, why do you multiply coefficient with subscript? But sir, in hydrogen, There is
Mhm.
4 and 2 also, na? So we can multiply it with that also. Why should multiply it with 1? Their oxygen.
If there isn't anything written here, like there's only one oxygen atom here, no, in this
Yeah.
compound, right? So when we multiply 4 with 1, like before 4 was not written here, so there was only one. But now since you have
Hmm.
written 4 here, so now it becomes 4 oxygen atoms.
But you can also multiply it with 2.
No, no, no. This 2 will not be multiplied by this. Okay, na? 2
No,
sub-
you can multiply 4 with 2, na?
how 4 with 2 I have multiplied it here, na? See? And here you are having now 8 hydrogen atoms.
So you're
Get
not
it?
supposed to multiply with that.
Yeah, see, basically the coefficient is always multiplied with the subscripts. Like 2 and 1 here are subscript. The subscripts cannot be multiplied. Getting it now? The two subscripts cannot be multiplied with each other.
So it should be either multiplied with, I mean, it should be multiplied
Coefficient,
with coefficient and subscript.
coefficient and subscript should only be multiplied. Okay.
Okay.
Okay. Let's take another example. Suppose we have iron, Fe is for iron, and we have got oxygen here. So that gives us Fe3O4. Okay, now that is iron oxide here. Okay. So
Hmm.
what do we do to balance it? The very first thing which we are going to
F,
do, again, count the number of atoms here.
E, and C.
One iron atom and two oxygen.
Sir, Fe cannot be written as F and E. It should be written together only.
Yeah, it should be written together like this. Capital F,
Oh,
small e. How many oxygen
okay.
atoms are there? Four.
4
Okay. Now, what should we do so that we get our answer here? What could we do here? Think about it.
into 3
Into 3 here now. So, into 3, that is going to give us 3. Okay. And here we are
into
having 2. Into 2, simply 4. Isn't it balanced
yeah.
now?
This one is easy.
This one was easy. So, we will simply put what? 3 here and 2 here. Got it? No?
Yeah.
Okay.
3 Fe plus. Okay.
Mhm. Okay. Now, suppose that here you are having NH3. Okay, and that breaks into nitrogen and hydrogen. Is it balanced right now?
No.
No. How many nitrogen atoms are there?
1 and hydrogen is 3. And
One
over
and
there,
three.
2
Two
and
and
2.
two. Okay, now how do we balance this?
First, you multiply it with 2, so that will give you the answer 2.
Okay, so we
That's
will
balanced.
write two here. Okay, but writing two here will change the number of hydrogen from three to
2.
no. Look here,
6 is
Halima. Six, no. They see basically whenever you add a coefficient here, na, that coefficient will be multiplied with the subscript here. What is
oh,
this? His this is subscript. We call that as subscript, and we call this as coefficient. Okay, now. So whenever you will add a new coefficient, every time you add it, it is going to get multiplied with the subscript. So 2 into 3, now it has become 6. Okay. Okay. So nitrogen was already balanced here, right? Now the new hydrogen number, new number of hydrogen atom is 6. Here it is 2. So what should we do to make it 6? Multiply
3
by
into 3.
3. So that becomes 6 and we will write 3 here. So isn't it balanced now?
Yes, sir, it is.
Okay, no? Okay. I'm going to give you some questions. Let's do the questions given in this. All right, look at the following question here. So we have to basically write the coefficients here. So again, basically we are going to look like how many oxygen atoms are there on the left,
Okay.
on the right side.
Oxygen and O3 plus
Hmm.
H2O.
Two oxygen
Uh,
atoms,
yes.
one nitrogen, and how many hydrogen?
3.
Three.
1
Okay.
and 3.
And here, how many oxygen atoms are there?
Hydrogen is 1. Oh, sorry, sorry. Oxygen is 6.
Oxygen is 3 plus 1. No, there is 3
Oh, that's
oxygen.
for hydrogen.
I mean, talking
2
about
is for
oxygen now.
hydrogen.
That too is for hydrogen only. See, let me clear out that confusion. See, if you see a compound like water, H2O. So it means that there are two hydrogen atoms in it and one oxygen atom. How many? Two hydrogen atoms. Like this subscript is written at the foot of hydrogen, na?
Oh,
So
okay.
it is showing that there are two hydrogen atom. Okay, na?
Uh-huh.
And here, if there's nothing, like you are having one here at the subscript of zero,
Yeah, that I
one here.
got it.
So oxygen is gone. Okay. So thereby you're having one oxygen atom here and three here. One plus three, that is four.
Four.
That is four. Okay. Now tell me how many nitrogen atoms on the
Nitrogen is one, and
hydrogen
hydrogen is
is.
also one.
Mhm. And hydrogen is also one. No, there are two
What?
hydrogen
Oh,
atoms
two,
here
two, two. Sorry, sorry, sorry,
and
sorry.
one here. No,
Three. That will be three.
two plus one, three. All right. Hydrogen is we are seeing like right now. As of now, it is already balanced. Okay. Nitrogen is
Yeah.
also balanced. Okay. Number of
Now
oxygen atom is different here.
two into two, that is four.
Simply all you have to do is put two here, right?
Yeah.
So two into two, that is four. So thereby there's no change
It.
needed over here. Only this one. Here we will write one, one, and one. That's it. Got it, Halima?
Yeah. Yes, sir. It
Okay,
was
look at.
fully balanced. Just we had to oxygen. That's it.
Mhm. Okay, now. Okay, tell me if Fe2O3 is written here, how many iron is there and how many oxygen is there?
Two and oxygen is three.
Very good. Now, if I were to write 5 here, so now the new numbers are, hurry up.
Uh, so you are supposed to multiply five to the
Hmm.
no,
That is
yeah, five to
uh
10
10 and 5 threes are
and 15.
15. Very good. Okay, let's solve the next question here. So,
Fe plus 2 gives you Fe2O3. So Fe will be 1.
hmm,
No, 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 wait.
hmm, obviously there's
Oh,
one,
yeah, it will be 1. And O will be 2.
and O will be
And
2 here
here,
and here.
and O will be 3.
Okay, what should we do here?
So first you multiply 1 with 2, which is 2.
Okay,
Then,
suppose you have written 2
uh,
here. Hmm.
then O will be O is 2 and 3. So you
Can we make them equal somehow by multiplying both of them with some number? Like,
yeah, you
what is.
multiply
Mhm.
3 with 2. That will be give you 6.
And
And
this with 3, that will give you 6. And this with 2, right? 6. Okay. So thereby, in order to do so, here we will have to put 3. And here we will have to put what? 2, right?
2.
Since you multiplied this with 2. Okay, now this oxygen, you are multiplying it with 2. So basically you're going to write down coefficient as 2 here. But here's the problem now. A new problem has occurred. Can you spot it?
2 Fe3O2.
Has
2
the number
Fe.
of iron changed?
Oh, Fe is 2 there in the second one.
And here,
That, 2. I mean 1. So you multiply. No, it's 2. 2,
once
sorry.
here, here there are two Fe. But now once you put 2 here, so this coefficient will be multiplied with the subscript. So there are 4 Fe here. So how about we
Yeah.
simply put 4 here? Will that not solve the problem?
Oh, yeah. You put 4 there.
Okay.
Then
So
see, over there, you're supposed to multiply it with something to get
no,
you 4.
no, why won't we? Because already 2 into 2 is 4 here. Look here.
Yeah.
How many iron atoms are there? 4 here. How many iron atoms are here? 2 into 2, 4. Okay. How many oxygen atoms are there? 3 into 2, 6. And here, how many oxygen atoms are there? 2 into 3, 6. Understood that or not?
This is balanced now.
Hmm. It is balanced now. Got it now?
Yeah.
Okay. Now look at the next question. See,
This-
these are called as radicals. or they're called as ions, charged particles. Okay, now they are charged particles. So we have to write the molecular formula for the following compounds. That is ferrous chloride, aluminum sulfate, sulfuric acid, magnesium oxide, and sodium carbonate. Okay, let's do it. So ferrous chloride.
Is it Fe plus 2?
For ferrous, we are going to use Fe. Okay, now Fe plus 2. And for chloride, that is going to be Cl minus 1. Okay.
Yeah.
Now we are going to use the crisscross method, right? So this one will come at the foot of iron. This two will go at the foot of chlorine here. Getting it? So that becomes FeCl2. Understood that, Halima?
So minus, uh,
So see, we are not going to write the minus sign here. Basically, like one comes at the foot of iron and two goes to the foot of chlorine. So that becomes FeCl2.
so instead of writing Fe, we can write Fe1Cl2.
No, one is kind of understood that if there isn't anything here, so the one is hidden here. So there's
Oh,
actually no
okay.
need. Okay, no. So that is FeCl2 for question number one. Okay. Similarly, look at aluminum sulfate here. For aluminum, which radical are you going to use here? Al is there
L,
Al?
Al plus 3.
Al plus 3. Okay. For sulfate, it is
A
SO4.
minus,
No, no, sulfate. Sulfate is SO4 minus 2. Okay, na?
yeah, SO4 minus 2.
So SO4 minus 2. So you will do the crisscross method. You will use that. Okay. So minus 2 will come here and plus 3 will come here. So you write Al2 and then you write SO4. Are we just going to write 3 like that? No.
Mm,
When there's already a subscript, when there's already a subscript here, so you are going to put that in bracket and then you write down this 3 here. Understood that, Halim? So
okay.
Al2SO4 whole 3. How are you going to read it? Al2SO4 whole 3.
Yes,
Hope you are actually understanding it.
yes, sir. I got
Okay.
it.
So tell me the answer for third question then. That is sulfuric acid.
Sulf for sulfuric acid, you write Na plus 1.
No, no, no. We have
Is
even
it?
learned about the chemical formula of sulfuric acid in the chapter acid bases and so on. See, sulfuric acid, na, it is made up of hydrogen, okay, and sulfate. Okay, how much is the charge? Or like how
H,
much is the charge on hydrogen?
H plus 1.
H plus 1.
SO4 minus 2.
One second. H plus we're going to write only. H plus. SO4 is minus 2. So this
Yeah.
minus 2 will come at the foot of H and
H,
plus 1 will go at
H,
the foot of. Mhm.
H minus 2.
Mm. No, not H minus 2. Again, you're confusing it. See, it's simply going to be H2 and SO4. Okay, no? 1 should not be written here. We're not going to write 1 here. All right.
Okay.
Hmm. Because if
H,
you were to put it like that, suppose, so thereby it's same as like SO4, one writing 1 does not make any change here. Understanding it now? 1 multiplied with anything is same, gives us the same result, no? So H2SO4. Look at the fourth question here. That is magnesium oxide. This one is simple. You answer it, me. Answer it.
Mg plus 2.
Hmm?
O minus 2.
O minus 2. Okay.
Mg minus 2 O2.
See,
Mg2 Mg2 O2.
okay. Here's the interesting part. See, we will write it as you're saying Mg2, okay, and O2. But since the subscripts are same here, they were having same charges, same positive charges, same number of negative charges. So they will be cancelled. So that is simply going to be MgO.
Oh, I get it now.
Got it now? Okay. Now let us suppose there was some XYZ component. Okay, let's we are having an X molecule or compound, let us suppose, and on that the charge is 2, and you're having y on that the charge is 4. Now you look what will happen. 4 will come to the foot of
X
x, and 2 will
Y
go
2.
to the foot of 2. So we will write it as x4 y2, but this 2 is going to cancel it. So that will be written as x2y. Getting it, Halima?
Yeah, because it's coming in the same table. So like two ones are,
Uh,
two twos are. X
mhm.
2 4.
Okay.
I mean
Now, fifth question, you answer this one. Sodium carbonate. For sodium, it is
SO minus SO4 minus
first you will write Na plus, no? Sodium, sodium. Hmm. And for
Na plus
mhm.
CO CO
3,
minus 2.
CO3 minus 2. Carbonate is CO3 minus 2. Okay.
Yeah.
And here you are having only plus 1. All right.
Na minus 2.
Just write it as 2.
Yeah,
Okay.
Na takes.
And here we can write 1 here, but we are not going to. Okay.
Yeah, seriously.
So
Because
that's
it's
an,
just
hmm. So that becomes Na2CO3. All right. So these were your required answers. Okay, na? Cl2, Al2SO4 whole 3, H2SO4, MgO, Na2CO3. Okay. Moving on to the next question here. One second.
it's
Hmm.
Na2. So okay then.
Hmm. You have written it, no, by the way.
Yes, sir, I have written, sir.
Okay. Also, you can look at the following question also here. Like we have got potassium chloride. Okay.
Okay.
Potassium
Yes.
chloride is broken into potassium chloride and oxygen here. So here we are having here we are having one potassium atom. Okay. One chlorine atom. And we had how many?
Yes.
Three oxygen atoms were there. And here respectively one chlorine, one potassium, and two oxygen. Okay. So we were saying that like potassium and chlorine were already balanced earlier. Like they were one here and one here. But number of oxygen atoms is different. Okay. So here we have multiplied oxygen with three. I mean to say sorry, two to get six. So when you will put two here, no, when you put two here, so you will have to multiply other two atoms. That is potassium and chlorine will also be multiplied with two now, right? So their number changes to two and two here. So here you have got oxygen as 6. In order to make oxygen 6 here also, you will have to multiply it with 3 now. Right? 2 multiplied by 3 became 6. Okay.
I have a doubt.
Tell me.
Sir, in this you wrote 2KLO3 that gives you KCl plus 3O, I mean KClO2.
KClO2.
KCl plus O2. Wait,
I'm not getting what you're saying. Look here, Halima, once again. Earlier, this thing is clear now. Like earlier, how many atoms were there on each side?
hmm.
Okay, one potassium atom. Okay, K for potassium, one chlorine atom, and three oxygen atoms here, right? O3 means three oxygen atom here. Similarly, here you are having one potassium atom, okay, one chlorine atom, and two oxygen atoms were there. Okay.
Sir, over there after that,
Mhm.
I got to know how to like put the numbers. Then there it is oxygen atom is unbalanced. Right?
Yeah, the different number of
So
oxygen atoms here. Mhm.
there you multiply it with 2 that gives you 6.
Okay.
And over there also you are supposed to multiply it with 3 to get 6. That is
Right.
balanced. Now why do we have to multiply it with 2?
Hmm.
Because that is balanced, right?
Good question here. See, here you had multiplied oxygen with two. There were three oxygen atoms. Here you multiplied with two. Okay. As you're multiplying here, so you will have to put the coefficient here as two now, right? Okay. Now forget about it for a while that we have not put the coefficient here. Earlier, when it was only KClO3, potassium chloride, how many
Hmm.
potassium atoms were there? One.
Then
How many chlorine atoms were there? One.
1.
Okay.
And
But
O is 3.
Huh.
Oxygen is 3.
But suppose if you were to write 2 here, so you know that if nothing is written at the foot of K, there is 1. If nothing is written at the foot of chlorine, there's 1. So
Hmm.
will the number of potassium and chlorine atom not change? Will it not be 2 into 1 equals to 2? 2 potassium
So
atom.
the
Will it not be 2 into 1? That is 2 chlorine atom now. Getting it, Halima? So while you had put 2 here to make the number of oxygen atoms 6, the number of potassium and chlorine atom also change. So thereby, they automatically get multiplied with 2 to become 2 and 2 here. Okay.
oh, okay,
So
now I get it.
since the number of potassium and chlorine atoms also change to 2 and 2 here, so here you will also have to change it to 2 and 2. Okay, and already we have multiplied with 3 here to get 6. So we will have to put
Hmm.
2 here also. Understood that now? And that is the required answer. Okay, at home try to practice more questions. Okay, so that will become clear. Okay, now look at the following question. Like in the process depicted below, sunlight, chlorophyll, carbon dioxide, water, and minerals are raw materials essential for photosynthesis. State with the appropriate raw materials in the following blanks. Okay, which one is available in the plant?
Uh,
Hmm. Chlorophyll,
Available in the plant is chlorophyll.
chlorophyll, no? Okay.
Yeah.
Next, available in the soil,
Protein and minerals.
water and minerals. Okay, that will be B. Available in the air,
Carbon dioxide.
that's C. And available during day, available in the
Sun,
air, we done, no? Available during the day,
sunlight.
then simple question. All right. State the product for the process of photosynthesis and its importance.
Uh, so I should write uh,
What
sunlight
is?
plus
No, you're not getting the question. Question is saying state the product for the process of photosynthesis and its importance. Then
what
you will
I
write
mean
the word equation for the process of photosynthesis.
product of photosynthesis is sugar and
You should be rather saying glucose. Okay, na? So glucose is the food produced during the process of photosynthesis, right? Na? And what is the importance? Like glucose, it's a simple sugar. You can say sugar, but rather you should say the product of photosynthesis is glucose, which is a simple sugar and oxygen, right?
yes, sir.
Okay, what is the word equation? Oh, okay, what is the importance of it?
Importance is that glucose will help plants.
Hmm.
No, no, no. Oxygen helps. Oxygen helps living
Glucose and
organisms.
oxygen, both of them have to be explained here. Like how both of them are important here. Hmm. Glucose is used by the plants to carry out its day-to-day activity, and it is also stored in different parts of the plant. Okay, na? Which we humans consume in the form of food. Then it releases oxygen, which is essential for the survival of living beings. Living beings cannot do respiration without oxygen, right? And this process of photosynthesis, it helps in maintaining the balance of oxygen and carbon dioxide gas in the atmosphere. Okay. Now you quickly tell me the word equation for it.
Good equation.
Yeah.
Carbon dioxide
Hmm.
plus water
Plus
gives
water
gives light energy and chlorophyll
gives
gives
light energy
yeah in the arrow up
in
there
okay, okay, okay.
light energy chlorophyll
Hmm.
that gives sugar plus oxygen
Glucose in the bracket we will write down sugar
plus
plus
oxygen.
oxygen. Okay.
Sir, the
Uh-huh.
chemical the other formula also.
Please repeat it. Oh, chemical formula. Yeah, that is
Yeah.
CO2 plus
Six
H2O. Okay.
plus 6H2O light chlorophyll
C6H12O6 plus
12O
O2.
6O2.
Okay, na? That's it. You can even balance it. You will put 6 here, right now. You will put 6 here, and 6 over here. So that will be the balanced chemical equation for it. Okay, now how many carbon atoms becomes here? 6. Oxygen becomes how many? 6 into 2, 12. 12 plus 6, 18 here. How many hydrogen atoms are there? 6 into 2,
12.
12. Okay. Are we having the same number of oxygen atoms here again? 6. C is equal to 6 here, right? Okay. How many hydrogen atoms are there? 12.
And oxygen is 6.
Oxygen is no 6 plus 6 into 12. Here you are having 12 and here you are having 6. So that is 18.
18, 18.
Uh-huh. So in order to balance this equation, we have put coefficients at three different places. 6 here, here, and here. Okay, Alima? So answer the following question based on the diagram given below. Okay, so here's the pharynx, here's the esophagus. Okay, that's the liver. Okay, so we need to fill this. Identify the glands labeled as A and B in the diagram and describe the secretion of A and B of digestive system and their role in digestion. Okay, so which gland is there? 1 second, it was A and B, no? Hmm. So A here is showing
Sir,
our
A,
mouth. So which gland secretes its secretion in the mouth?
wait. The gland is salivary gland.
Salivary gland. Okay, okay. And B here is,
B is liver.
which is the largest gland in your body. Okay. Hmm.
Yeah.
So tell me about the secretion of both salivary gland and the liver, and how do they play an important role in digestion?
Salivary gland.
Hmm.
Sir, when we chew food, the salivary gland mixes with the food, and both chemical and physical.
1 second, 1 second. Salivary gland secretes saliva, which contains an enzyme. Okay, na? Like
Uh,
salivary gland secretes a watery fluid called as saliva, which mixes with the food. It moistens the food and makes it soft and easy to swallow. And then it also contains salivary amylase. Remember that. It contains an enzyme by the name of salivary amylase. Now, this salivary amylase, what does it do? What is its function?
it break large and complex substances.
Into simpler molecule.
Yeah. For example, carbohydrate part and protein into their simplest form.
You shouldn't be talking about protein here. You should be only mentioning about the starch. It converts starch into a simple sugar molecule that is called as maltose. If you remember, we have discussed it in the class.
Yeah.
Okay. Tell me about liver quickly.
Liver.
Hmm. What
I
does the
should
liver
talk
do?
about what?
Like, what is its function? In
Oh.
the second part, it's saying to describe the secretion and their role in digestion. No. Hmm.
Liver produces bile,
Hmm.
and bile juice is stored in um, in a sac-like structure called gallbladder,
Hmm.
which is connected to the liver.
Okay.
And bile juice helps to
In
like
digestion of the fats. Okay. What they do, they will be breaking the large fat globules. Like if there's a large fat globule, it will be broken into smaller fat globules like that. Okay, na?
bile bile mixes with the fat.
It basically acts upon the fat and breaks the large globules. We call this as large globules of fat. They are converted into small globules. Okay, Halima.
Small particles, by the way.
Small particles, basically. From large particles, they are being broken into small particles like that. So they play an important digestion. Okay, now liver, you know that liver also helps in detoxification, right? Now it also helps in cleaning our blood, by the way. Okay.
Yeah.
Okay. Yeah. Further, we have got question number 31, 32 is also there. Okay, let's discuss this one. Alimentary canal is different from digestive system. It says that alimentary canal is different from digestive system. We need to justify this statement. So, like, is it that alimentary canal is different from the digestive system? We know that alimentary canal, it refers to the long continuous tube through which the
Yeah.
food passes in our body from the mouth till the anus. Na?
Yes, sir.
From our mouth, this starts.
It
Next,
is 2 meter long, I guess. Is it 12 meter long?
one second. Next is esophagus. After that,
Then
hmm,
esophagus, then liver.
no,
Yeah. Okay. Yeah. Sorry.
glands are
Stomach.
not part of it. Hmm.
Stomach. Then large intestine, small intestine, and then anus.
The small intestine, large intestine, and the anus. Okay. So alimentary canal refers only to this long continuous tube through which food passes in our body from mouth till the anus. But on the
Yes.
other hand, the digestive system, it includes the alimentary canal along with the accessory glands, along with the digestive glands. Getting it now? So when we talk
Liver,
about Mhm. So their
digestive.
digestive gland is also there.
First is salivary gland,
Yeah.
then
Yes.
liver, then gallbladder, pancreas.
Gallbladder is not a gland. Gallbladder just stores the bile juice. Okay, na? So
Okay.
digestive system talks about the alimentary canal like this, along with the
Along with the
alimentary canal along with the digestive glands. Okay, no? So that is
yeah.
your digestive system. So that is the difference. Alimentary canal is actually, we can say that alimentary canal is part of the digestive system, but the digestive system is a broader term that includes both the alimentary canal as well as the digestive glands, which secretes digestive juices. Hope that is clear to you, Halima. Okay, na?
Yes, sir.
So try to do the question number 31, 32, and some other questions at home. I already had